My name is Nick Krantz. I'm a software engineer at Livefront, and welcome to What in the World is Happening on the Web. When I first started this, I was kind of overblown of how fast the web moves, so I really wanted to start from the beginning, which takes us to the early 1990s. 1989 to be exact. Tim Berners-Lee invented the World Wide Web as a tool to automate information sharing between scientists. He worked at CERN, which is the European Council for Nuclear Research, and if you think that acronym doesn't add up, in French it does, but I will not try and pronounce it in French. Shortly thereafter, in 1990, the first web browser was invented, also called the World Wide Web, just no spaces. Quickly renamed Nexus to avoid that confusion. And you can still view this browser today. They did reboot it, and it looks a little like this. Very, very nostalgic, maybe, for some people. Very obscure and not fun for a lot of other people. The link will be at the end of the presentation. You can grab it, but I would recommend go playing around with it and seeing what it was like to navigate a web page in 1990. In 1991, HTML tags were introduced. There was 18 of them. You had your headings, list, body, title, simple things like that, links just to navigate around the web. The current HTML5 spec has 112 tags, so we are very far beyond those first number. If you look at deprecated tags that some browsers still support easily, that number can hit the 130s. Also in 1991, the first website went live to the public. You can view it at this URL, and it looked a little something like this. The computer was obviously very different than the rebooted one they had, so it was very black and white and in the form of earlier. And if you're like, oh, this is fantastic, this is exactly what I need, I mean, it flies on your Lighthouse scores. So you will be pleasing Google very well. Jumping a little forward into 1995, JavaScript was initially released, and if you are a JavaScript lover or if you're a hater out there, a lot of things might be explained in the fact that it was developed in 10 days. So if you think about your work, what you do every day, just know that a language is developed in 10 days. So that's a high bar, but also kind of explains some of the quirks that were there. 1996, CSS was initially released. And then that brings us to the major three players we have on the web. That's how web pages were built back in the 90s. That is still how web pages are built today. Moving us forward into the 2000s, I think is really where the web started to scale and how we're going to scale web development and make it easier. No one wants to maintain 300 indexed HTML pages on different file paths on a server. That's not a great development experience. So code reusability and modularity really came into the picture. Abstractions, so if you were making a whole bunch of API calls, you could abstract that HTTP layer away maybe by a framework. Speed of development picked up by the above two bullet points. Obviously makes things a little faster. And I wanted to throw server-side rendering in here because that was the only option. A web page lived on a server, it was served to the client. So if we think about different technologies that were used, PHP was a big one. Wikipedia and Facebook were big players in PHP. I believe Facebook still has PHP running to this day, which is pretty cool. Django is a Python library. ASP.NET is a C#, and Ruby on Rails is Ruby. Notice I didn't say anything about JavaScript here. So the frameworks that I think first kind of made a huge push in the web had little to do with JavaScript. There was only a server component to those, so if you did want to add interaction on your client, you did need to bring JavaScript and ship JavaScript with your code. And that is where in 2006, jQuery came into play and made a whole bunch of improvements to the client-side navigation. So you could easily select an element, hide it, alter the tech contents, hide show, all of those kinds of nature. Brings us back to my HTML, JavaScript, and CSS. We will have a recurring theme here. Taking us into the 2000s, into the 2010s, the teens. The single page application became very popular. SPA, if you ever hear someone talking about a SPA app, it is a single page application. So instead of multiple pages being fetched from the server, we're going to get all of our application code at once, and we're going to render it in the browser. Everyone was like, browsers are super fast. We can do this. It's going to be awesome. It is still awesome, but there's some downsides. The application is fully loaded on the start. It dynamically loads that content, so if you need to go make an API call to get a list of details or a profile, you make that from the client. It then comes back to the browser and renders. That also involves client-side routing. I think a cool user experience is not having to see a full page flash. You could navigate and do animations on the client side, which was pretty cool. But there are benefits to seeing like the browser go into a loading state because that's intuitive to a lot of people. And it's served as static files. So instead of having a Python server running or Ruby to serve those, you could just serve your HTML out of a cloud bucket or your local machine, and your web page would load from there. So it scales really well. I wanted to just kind of gloss through the kind of three major players. If I don't mention your favorite framework up here, I apologize. There's a bunch of them. Angular was a huge one. It was backed out of Google. React came out of Facebook, now Meta. And Vue, I think, is the third kind of major player in the SPA world. And that was just developed by Evan You. So kind of interesting to look at huge companies investing in their web architecture, and Evan You did come out of Angular and did a lot of Angular, and he didn't like how opinionated it was, so he wrote Vue to be very less opinionated and strip out all of that. And as mentioned before, these all run on the client, so if you are writing React code, none of it is running, at this point in time, running on a server anywhere. You're going to be running this in a browser. All right. That'll take us to where we are here today, in 2020s. I kind of think of it as eating at Cheesecake Factory, where you just have a menu that has so many options, you don't know what you're gonna have until you get there and you're really feeling it. So I chose 6 out of I looked at the State of JS, which is a website that does a poll of JavaScript frameworks and experiences. I chose 6. Left to right, top to bottom, React, Angular, and Vue. As mentioned, Svelte, Quick, and Solid are relatively new in the SPA, or framework game in the JavaScript, in the grand scheme of things. And I wanted to divide up how I talked about these frameworks. It was really difficult for me to research this topic and not try and become an expert in every single one. That would have taken a long time. So I broke it up into 3 major parts. Updating the DOM is one. Reactivity of how your state updates, and how we're going to then change our model. So Angular, Solid, Svelte, and Quick all use a form of reactivity. They're all implemented a little different. But if we look at a little example here, I have my mini browser with a button that will increment my count, and my number will change. So if I look at the JavaScript that corresponds to that, I have my variable count, and then a method that implements it, and my corresponding HTML. This is actually valid Svelte code. If you're a Svelte person, this is valid. If you're not, then it's not valid, so it will rake. So if I click my button, my increment method will run, my count will then update, which will then be tied to my HTML in some mechanism. We'll get into the nuances of each framework in a second, but then it'll be directly correlated to that HTML, which will then update my count to 0. So that's at a very high level how reactivity works. And if you're thinking, oh, I looked at this list and React isn't up there, it's because React isn't reactive, which is a fun naming problem. Here's a tweet from Dan Abernov, who's on the core React team. And if you learn anything from this slide, you now know that React is not reactive, and that your naming struggles exist with other developers as well. So they renamed an entire framework after something it's not. React and Vue actually use a virtual DOM. And so what does that mean is that's basically a DOM that's keeping the status of the DOM that is in the browser. So you can avoid having multiple mutations that are unneeded. So back to our simple example. I represented my virtual DOM here as a tree of nodes. We have a div with our paragraph that leads to our count. And then if I click my button, it's going to re-render that virtual DOM and with the updated state, and then it's going to go through a reconciliation process and identify what nodes need to be updated. Here we just have my count node, so then React can know, or Vue can say, okay, I know what DOM nodes I now need to update, which will relay my count being 1. All right. Another big part of frameworks is how they're composed. I think it can really make a difference between how everyone's mental model works or doesn't work and what makes sense to you. JSX is a very popular one. It looks a little differently across frameworks. Here's just generic JSX. So you have a function that returns your HTML, a way of injecting HTML into your JavaScript, not the other way around. If we get into React, here is some React code that would go along with my demo. We have use state. So this is the way that React is going to keep track of what should update my view. If we update the count and use set count to reset it, it will then trigger that re-render, and my increment count component in this instance will all rerun. Signal is very similar. The only major difference is it's called create signal instead of use state, and it returns a getter and a setter. So instead of count being an actual value, it's a get method. And the way solid works in its reactivity is there's a proxy on the other side of that get, where if you call it, it then logs that and that proxy catches it. So it knows that that paragraph tag is where that value needs to be updated directly, which is pretty slick. Quick. Quick is a fun one. I actually gave this demo to my wife, and I was like, this one looks totally different. And she's like, it looks exactly the same, because she has no ideas what we're talking about. But to me, it looks totally different because of all the dollar signs there. Quick does a delayed execution. They delay as much things as possible. So if you put a dollar sign somewhere, you're essentially telling Quick, like, hey, you don't have to run this until you need to. So that's what's happening on increment. Increment won't be called until that button is clicked. It won't be loaded, for instance, is what I mean by delayed execution. So that JavaScript won't be loaded until you click the button. Same with the component. If I am conditionally rendering increment count, that JavaScript also won't be loaded until it needs to be rendered, which is pretty cool. Results in a very, very low JavaScript page load. Angular, now we're out of side of the JSX kind of land, and we're in an Angular component. Angular is unique in that it uses classes and a decorator to tie together the class and the template. So here you can see I have a component with a template URL that relates to the HTML. And then everything public inside that class is accessible in the index. View, we have a view template, so now we're kind of back to a single file. So these are .view files. And inside my script tag, which is native HTML, you can write all your JavaScript that you need for that component. And then inside a template tag, you can write the associated HTML. The only difference here is view can use a @ or a V hyphen to do events. Otherwise, pretty similar to other implementations. Svelte, on the other hand, I think there's a talk out there by Rich Harris, one of the developers of Svelte, who says the easiest way to fix your code is to delete it. So I think that's kind of an interesting take, but it also says like there's barely any code here, and there's a lot of magic that Svelte does in the compile step. So your HTML that you write is default exported out, and then the equality selector in your increment is actually what triggers the reactivity. So if you're reassigning the value of count, it will then trigger a re-render. All right. Another important aspect, and my third kind of final one, is where does your code run? In a single page app, as I mentioned before, you have your HTML that's loaded. But since we need that JavaScript to load to render that entire page, your initial render is going to be a white screen. So if your user is on a very slow connection and that JavaScript takes 5 to 10 seconds to load, you're kind of stuck at a white page until that happens. So your JavaScript would follow, and then you'd go through an execution and a render stage, and then your user would then be able to interact with your app. Here I have a demo app that shows a Spotify playlist, for instance. Server-side rendering, which is becoming around, we're going to come full circle from what the web used to be, single page app to the browser, and now we're back to server-side rendering here today. There's tons of frameworks that do it, Svelte, Angular. The mountains are Nuxt, which is a Vue framework. Solid, Remix, and Next. Remix and Next are React frameworks. So on server-side rendering, we have our HTML. But the server was able to fetch our API, fetch my playlist, render all the songs, the images, etc. So our HTML will be a little bigger, and the user will see all the content on the initial render. But since there was state that occurred on the server, that state has to be translated to the client so that app can pick up where it left off. Wow. And that process is called hydration. So our JavaScript's going to load, and it's going to re-execute all of our JavaScript that just ran on the server, except the data fetching. So there's not going to be an API call, but it's going to pass that too. And we're going to go through that hydration step, and then I can have a user interaction. The reason that you can't have it on the initial render in this scenario is the event listeners need to be attached to buttons and things of that nature. If you do have native browser implementation like a link, that'll work on the initial render because it doesn't need any JavaScript associated with it. All right, and so the outlier of the day is going to be Quick, which is now a resumable framework. And by nature, the state is serialized into the HTML, so we're avoiding that hydration step of needing to rerun our app. Everything in the state is going to be attached to the HTML and shipped to the client. There's a single event listener. So as I mentioned before with the $ in Quick, the delayed execution only happens because about 1 kilobyte of JavaScript is loaded, listening for any click, and it will load or execute the JavaScript associated with that interaction, which then results in delayed execution. So if we think about that, that means that there is server-side rendering going on, in quotes. But the HTML is shipped with the state, and again is going to give us an initial render and a very quick, well, no pun intended, user interaction at the end. And then JavaScript is loaded there as it's needed. All right, let's check it out. I'm going to set this down soft. There we go. So here I have a React app. This is a create React app, so this was no longer suggested in the React docs to use, actually, but I just made a very simple React app that will, I'm going to have to get creative. Is this microphone on? All right, we'll roll with it. That's not going to work.
You could stand it up. It should work just.
That seems dangerous. All right. So here I have my Create React app. And if we look at the network tab, I'll refresh here. And we can see my playlist document was served. But there is 0 things in it except a div of the root of what to run, and then a no script tag. So we can simulate a very slow 3G network. And if I refresh my app, even from my local machine, it'll take a long time to load. There's my white screen. Now my JavaScript is loading in, and these images from Spotify are very big, so they will take a long time to load in as well. So that is kind of the network, or the problem that I think server-side rendering solves, is we no longer have this in-between state of not being able to see anything on the screen for a slow network user. Let's turn this to throttling. We will jump over to Nuxt, which is a Vue implementation of the same application, but it is server-side rendered. So if we refresh my page here, we'll take a look at that same document, and you can see there's a whole bunch of stuff here, which is awesome. We will click into a playlist. How about songs that have to do with Minnesota? And then there's that hydration step I talked about. So if we wanted to sort this table, that hydration step has occurred. We can sort by duration or artist. Weird Al put quotes around his name, I think, just to get to the top of a sorted list. But we have a title. So if we actually disable JavaScript here, and then refresh my page, you can see I have some red blocks, so these JavaScript files didn't run. So I have 0 JavaScript on the page, so that means I cannot sort. So this would be what happened if your hydration got interrupted by a JavaScript error, a client-side error, or the user disables JavaScript, which is very uncommon, I believe, except just doing it here for demo purposes. We will re-enable JavaScript. And my third implementation is Quick. So as I mentioned in Quick, refresh, we'll look at my playlist. Oh, there's a lot of styles here. all of my CSS is also embedded in the HTML. And you'll see that all of these comments have to do with the quick compiler, and they're relaying information to the running JavaScript on the page. So if we open up my Minnesota playlist already, and if we look at this artist button, here it is. I didn't ask if this is big enough. I hope it's big enough. We can see my onClick is associated with a JavaScript file. So if we look at this JavaScript file, Q67 something, and we'll clear out my console and I'll click on the artist, we're going to see that JavaScript is loaded on the fly, and that is going to do the sorting of my table and then return and back, and it's going to update, which I think is pretty cool. So that takes us to where we are today, and I think looking into this, I was kind of expecting to come out with an answer of like, you should learn X. I think that's kind of the wrong approach. I think now is a great time to be on the web. There's so many frameworks out there to learn. So I think it's finding one that's interesting to you. Quick is super interesting that it doesn't load JavaScript right away. So you have that low cost, but maybe that doesn't matter to you. So maybe Svelte or React or something I haven't even mentioned today, because there's probably a new one that got invented since I started talking 20-some minutes ago, is a way to go. So thank you for coming. I appreciate it. Happy to chat or take any questions. If you want to look at the code used to make all of those apps, it's there. You can scan the QR code. Livefront also has a lot of minibar representation, so there's other talks happening today, or feel free to connect with me.
Where I really struggle with clients right now is I don't know what the future of the internet looks like.
Right.
So that almost takes me back to thinking a lot of money is spent on web design, things like that, maybe even app design. But if we're getting into a world where search is based on being able to quickly find information and return that information in that search ecosystem or whatever, do we almost go back to that very basic internet where your website becomes less important because it's about being picked in that discovery phase?
Yeah, I think that's a great question. Not an SEO expert, so there's a ton of reasons why you slide up and down Google's results page. Making that information easily accessible is a major part of that. So in the client side, or the SPA app era, that was really hard because all that JavaScript had to load to generate the HTML for Google to parse. So that was kind of, you saw a lot of downfalls. And that's why I think server-side rendering is coming back around. Of companies need to be out in the world, and that's how people find them, is through Google. So you have this aspect of, we are kind of going back of how simple can we make our landing pages. We've worked with a couple clients who have a specific marketing website who is just static HTML that's sitting out there, just static pages, easily updatable through a CMS. And then they have portals into full-blown applications that are SPA apps because they don't need to be on the search side, but the search side is there on the marketing static pages.
What is the developer experience like between the different frameworks? Did anything stand out to you about how one does it compared to the others?
Yeah, I think it's a great point. I'll go back. Let's see if I can. I'm a React developer, so this makes a lot of sense to me. In React, you have a lot of stuff you have to tell React. So I have to tell React that this view can update based on this state. And that can get blown out of proportion tenfold if you're working on a very complex application. I think that's kind of the cool thing with Svelte is I'm not telling Svelte anything here. I'm saying I have a view that has a button, and I'm just going to change the value. And view, during its compile step when you build all your JavaScript, is going to handle that for you. So you don't have to have space hatches, like use memo or use callback in React to then say, oh, you don't have to render this because my props haven't changed. Here, you're just writing pure JavaScript. So that's really what stood out to me when I was going through this process of how can I take away things I have to think about and rely on the framework to do it for me? Part of the downside of that is there's magic happening here. So if you are coming from a React world and you look at this, you're like, so it just works. And that could be confusing. So it depends on what your team and what you kind of find intuitive. Yeah, go ahead.
Why do you think it is we have such a wide range of frameworks for web relative to other forms of computer science?
Good question. I almost think because there's so many problems you could solve on the web, going back to like the SEO problem. Some applications have zero SEO needs. They're behind paywalls, they're linked, they're not behind paywalls, behind authentication. So it's an actual app. You go to someone's homepage and log in. So different problems require different solutions. Quick, for instance, is great at static sites because you don't have to load a lot of JavaScript with that. Astro is a new framework that came out within the last year or two, and their focus is on static sites as well. So you do have so many problems, and every framework just creates new problems. So then another framework's going to pop up and be like, oh, well, we took this away, and so you don't have this problem, or we put a solution on top of it. So I think that aspect to it of different problems and solutions, and then just so many opinions, and the web is so free-flowing of developers can just run wild, I think is really fun. Yeah, good question.
So I work with a lot of small businesses, and oftentimes small businesses don't have the resources to get a developer to work on their webpage or dedicated to that webpage. So they oftentimes go to different consultants or other third-party development houses to go and work on these projects. My question is, how do you choose a framework that could be supported by one day a small business has money and they pay for their webpage, and then they fire you because they don't have the money to sustain it, and then they go and they've grown and now they need to update it, right? So now that new developer needs to take on this project that just has realistically very minimal or really crappy documentation, right? Or if it's in a weird, obscure framework, they have to learn that new framework. And I don't know, do you have any thoughts on managing that?
Yeah, it's not a great business problem, but it's a business question you kind of have to ask yourself when picking something to do. If Quick just hit a release candidate of 1.0, so if you were to come to a client and be like, oh, we're going to write in Quick, we don't know if Quick's going to be around in 3 years. So that's kind of a pro and con you're weighing. So if you were to look at, Ruby on Rails is still super popular today, and even though it came out in the mid-2000s, I think, yeah, early 2000s. So that could be a really strong choice. Like, this has been around forever. So your talent pool you could hire later. React, Angular, and Vue are the three kind of main players almost still today, whether you have a Next or a Remix or something else building on top of them. So you have to look at what has been around and where are we going to kind of make that decision, because you don't want to leave your client in a poor decision of, oh, I did what was cool in 2023, and in 2024 it died out because their community wasn't there to support it, the developer and talent pool wasn't there. So you kind of have to weigh those costs of what your choice is. Thanks, good question. Chris.
Do these frameworks interoperate nicely, or do you have to pick one and kind of roll with it?
Picking one and rolling with it is definitely easier. You can integrate with them. They are UI frameworks for the most part, so if you get into slide with a lot of frameworks on it. Here it is. How did I not just end up on that slide? Oh, I did. I just didn't hit next. Okay. So if you're using Remix, you wouldn't really integrate with a Next app directly because those are kind of full-fledged, like full-stack frameworks of running on the server and code. But if you had a Vue UI template or a React just UI template and you weren't using necessarily a full-fledged app, you could integrate them. You would go through some pain points of you need to ship React with the React code to then update and render. But there are, oh gosh, there's a framework out there that's like noted for that of like, yeah, whatever library you want to use. It's like micro front ends. So instead of like microservices, you have like, oh, if you want your drawer on the left to be in React, like sure, we'll put that there. And if you want your like profile on the top right to be in Solid, we'll do that too. So I forget what that framework's called, but it is interesting. Astro? There you go. Astro. Thank you. Sure.
Do any of these frameworks have anything to do with the technology that your APIs are written in? Are there any of them that work better because they can handle things, authentication, whatever? I mean, I know it's all JSON.
As a web developer, I personally don't care too much. I think authentication is when you starting getting opinions. If you have a full client-side app and you have secrets that need to interact with your API, it's really hard to get around that authentication error if you need to have a secret token to interact with that API. If you're running code on the server, you don't have that issue because your client no longer interacts with that. So for the most part, no, but there are certain niche aspects. I think authentication is probably the big one of how you want to authenticate and protect your API.
So do any of these work better for that kind of application?
Yeah, so if you have, all of these ones actually all do server-side rendering. So if you had an API and any one of these services, frameworks, you could make those API calls from the server side. And then so you could have an API from your client that would make a call to your same endpoint that's serving your files, and then as a proxy go to your authenticated issues. So Angular does server-side rendering pretty well. Remix and Next also do it. Svelte Kit and Solid on the far left and the right also do it. So none of them I can say like oh, you have to go with this one for that reason. That is a very common problem on the web, so they all handle it very, very well. Yeah, good question. John. Good question. So with accessibility, your question really comes down to how you write your application. So it really comes down to, I don't have a slide for that. I was going to think I did. Your HTML should be structured the same across all of them. So if you have a, what is a good accessibility example? If you have a drawer, so you have a drawer on your left-hand side, you should have the JavaScript that's going to shift focused into that drawer. And then if it's, you want a trap focus in there, so you have JavaScript listening of like, oh, you tabbed in and you tabbed out. So then if that drawer is closed and your user's tabbing around the screen, you shouldn't be able to access that drawer. So those problems exist across all frameworks, and it really depends on how your HTML and JavaScript is written, which you can do across all of them the same to handle those scenarios. Screen readers the same way. Your HTML should be semantic, so you need to have great HTML scores at cost of 3, which I think is a great point to bring up accessibility. Yeah. All right. Thank you, guys. I appreciate the time.